Okay, so hi everyone. My name is Sebastien. I'm working in France in Dijon, and I'm going to present an ontology-driven LLM framework for an automatic knowledge graph creation into smart buildings. So, oh, okay. Oh, sorry. So about the contents, first I will expose the motivations, then the analytic work, some key concepts, the approach, the results, and I will conclude. So about the context and motivations, the buildings in exploitation, they represent 1/3 of the global energy consumption and 1/4 of the CO2 emission in the world. So they are actually at the forefront of many policies, regulations, and decrees all around the world in order to reduce this consumption, to reduce the CO2 emissions. And the question is how to know if the building behavior is corresponding to the regulation that we try to set. For that, one solution is to digitalize the building with sensors and IoT in order to know what is happening in real time in the building. And so this leads to two main concepts, data-driven smart building, which is a building that uses digital technology to optimize its energy, for example, and digital twins for buildings, which is a digital replica of a real entity here, the building, which enable decision making and performance optimization. So the main question is how to make a digital twin from a real building. First, we need the 3D assets coming from the BIM process. Then we can add some IoT to have the real-time time series data. At this step, we've got what we call a digital shadow, which enables we can do monitoring or energy auditing. Then we can add some AI or rule-based system in order to let the building make some decisions. And the last step, we've got a real digital twin with simulation prediction, and it can give a feedback to the real entity. Of course, it's very expensive. We've got many gaps to build this digital twin. Sorry. So first, the cost is very expensive, and also the industry don't know the value of this kind of tool. There is a lack of standard tools too, and a lack of value propositions. So my work is about addressing this lack of generic tools. The first thing is we've got a lot of data, and how to contextualize this data in order to get some and to retrieve some information. For that, we can use two tools, so ontologies and knowledge graph. An ontology, basically, it's structured organizations, formalized organizations with formalized vocabulary and structured taxonomy in a graph-based format. You've got an example of an ontology here, which is called a real estate core, which structures the building, which contains floors and rooms and sensors and the values of the sensors. And the knowledge graph is related to ontology, but pretty different. It's more about storing knowledge in a graph database in a machine-readable format. So the main problem is that the data are stored in two different silos. We've got silos for metadata, from time series, and from assets, from the BIM process, and so on. And the first thing is that if we want to create a digital twin, we have to break these silos to contextualize the data together. And it's very hard task, very time consuming, and so on, because of the complexity of the data and the heterogeneity of the data. So on the next slide, I will propose a method to automatically structure this data driven by ontology. And for that, I propose to use LLM with the RAG method, RNG method. So I think that everyone knows LLM, ChatGPT, and so on. The main problem on LLM is that they can hallucinate. They can produce false information that appears to be true because the text has been correctly generated. And for that, the retrieval augmented generation has been set up a few years ago. In fact, basically, you provide a context to your LLM, and you ask to the LLM to retrieve information from your question within this context. So it helps to reduce the hallucinations. And with that technique, you can use LLM locally with your own private data. So about the approach, so I'm very lucky because I'm working into a brand new building in France, which is equipped with more than 3,000 sensors. So I've got a lot of data, a huge amount of data. And I've got two databases for the metadata, data describing the data, in fact, and the time series, the values. The main approach is here. So first, I use the RNG, the retrieval augmented generation approach, but instead of but as the context, I use a standard ontology, so real estate core, as the context of the RNG method in the first step. In the second step, I ask to the LLM for each of my metadata, give me a description of my sensor and of my space, of my topology of my building that I've got into the data with the correct font. Then in the third step, this is the RG method. I use a similarity search in order to retrieve automatically the correct type of the ontology from my description, the type of the sensor and the type of the space. Then once I've got the correct concepts, I just have to connect them together with the time series, with the values, in order to build automatically a knowledge graph and to store this knowledge graph into a JSON file. The third step, I can reload the knowledge graph into graph database, which is Neo4j here, to explore this knowledge graph. So I've got the building, which contains the floor, the rooms, the sensors, and the value dynamically. The experiment, so the challenge was to retrieve 32 types of spaces, classroom, laboratories, and so on, and 42 types of sensors, humidity, temperature, occupancy sensors from my buildings, from the ontology, which contains 92 types of spaces and more than 200 types of sensors. For that, I use three small and open source LLM, Llama, Mistral, and Gemma. And I split the result on the first evaluation on the left into three categories for correct, ambiguous. Ambiguous, it's when, for example, the system retrieved hygiene rooms instead of toilets or things like that. And incorrect. All the ground truth has been done manually by myself. The third evaluation is pretty interesting too, because I've got a graph database. I can query this database to evaluate, for example, how many restroom do I have, how many kitchen do I have, to set and to compare that with the ground truth. So to conclude, I've presented a method that automatically builds a knowledge graph from the data provided by a connected building. For that, I use a standard ontology from the literature to guide the model and to structure the data together. I use a LLM with the RNG method to automatically retrieve the concept. And about the perspectives, the next step would be to enhance the knowledge graph with BIM assets, for example, and to connect the data that I've got with the BIM asset. We can also change the ontologies. I use reliance and core, but we've got many ontologies in the literature that I can exchange. Many tests could be done on the prompt. The prompting is very important to retrieve the concept. And the next step would be to use graph machine algorithm with graph neural networks in order to get some insights from the knowledge graph. For example, to detect some anomalies, to predict some values, some clustering, classification, and so on. Okay, so thank you, the acknowledgement and contact information. Thank you.